Okay, so in this video, we're going to deal with all of factor markets in one page, which is pretty nuts. Factor markets are usually something spread out a little bit more, but I'm trying to give you just the bare minimum to help you review. I would encourage you to go back and check out those other YouTube videos if you need more practice. So two variables affect what we call factor demand. Before I get into that, it might be a good idea to remember that factor markets are markets for land, labor, and capital, which would be the factors of production. That's the definition of a factor. So that's one quick thing here. Factor demand is derived from, let me use A and B for these. It's derived from two things. And those two things are the price of the good being produced, and we would say the productivity of the factor itself. So how much the factor can produce. And we would say that it's called derived demand because factor demand derives from demand for the good. In other words, we have none, we derives from demand for the good. We don't demand the workers unless they're actually producing anything of value. And kind of we're actually seeing that right now in terms of the coronavirus pandemic, right? You don't need workers if there's no demand for people in restaurants. And that's a big thing crippling current employment numbers. Now, what affects factor supply? Well, it's primarily people's willingness to work, which is affected by, and this is usually we see this kind of question about labor. So we think about their leisure value that they place on it, and how much they value their time and things like that. Their perception of the work and that sort of thing, how rewarding it is. We often would also say the quantity of labor just in general. So if there's things like immigration can affect people's factor supply and things like that. The cost minimizing input combination rule. Woo, what a mouthful. It's designed, it's a rule to help know how many of each input to hire. So let's say, how many workers, how many machines. And the simple rule is given as hire the quantity of labor and capital where we satisfy the marginal product of the last worker we'll say the marginal product of labor divided by the wage that you paid to that worker is equal to the marginal product of that last machine divided by the rental rate of the machine. So this is the marginal product of last worker hired divided by wage has to equal the MP of last machine divided by the rent on the machine, or the price of the machine is kind of one way to think about that. Now, if the last machine, this is the example of the problem here, if the last machine hired generates 5 grebes per dollar, which would be the marginal product per dollar, and the last worker generates 8, how should the firm reallocate? Well, 5 is less than 8, and the 8 comes from labor, and the 5 comes from machine. So the firm should reduce spending on machines and increase to labor. They should hire fewer machines and hire more workers. And in so doing, this 5 will become bigger and the 8 will become smaller until they equal each other. And I remember in class I did a little Pac-Man where you eat more workers, and that's kind of a little bit disturbing. So maybe don't imagine that. Marginal revenue product. So MRP is the value of the product produced by the last worker hired. So another way to think about it would be, what's the marginal revenue, the additional revenue from that worker? And the formula you could do in a variety of different ways, but we would say it's the change, so I'm going to put it down here, change in TR divided by the change in quantity of labor. So typically you would have change in quantity of labor 1 because you hired one more worker. And so whatever the change in total revenue is from that worker would be the marginal revenue product. The marginal factor cost is MFC. It's sometimes called the marginal resource cost, because we use the two words resource and factor interchangeably. It is the cost of each additional factor. And so it's just given as the change in total cost divided by the change in quantity of labor. Or, if we're talking about machines, it would be the change in quantity of machines or whatever. So this wouldn't necessarily just pertain to labor. It could be machines as well. The input hiring rule, just in other words, this is also saying, AKA how many workers to hire, is quite simple then. It's actually just hire the firm's inputs higher until the MRP equals the MFC. And so this is our simple rule. You don't hire any worker. Don't hire workers where MFC is bigger than the MRP. That would be silly. You would not hire a worker where they cost you more than they bring in. Okay, so now we're going to do quick last graphs of the whole thing here, the last kit and caboodle, side-by-side graphs, oh, that's ugly, of the labor market and a firm. And we're going to notice some differences and similarities with perfect competition. First is we're going to use wage instead of price. We're going to say QL and QL. We have a downward sloping demand for labor, and that's made up of firms. And we have a supply of labor. So I'm just going to put supply of labor is the workers, right? The workers. And demand for labor is the firms, because they're the ones doing the hiring. They want to hire workers. And there's an equilibrium wage getting paid, W star, and an equilibrium number of workers hired, Q star. And this firm is a wage taker. Because it's perfect competition, we call it a wage taker. And in fact, both parties have to just take the equilibrium wage. The workers can't say we want a higher wage, nor can the firm say we want a lower wage. It is what it is. So the wage is the wage set by the market. And now, here's where it gets a little different from perfect competition. So if you think about perfect competition, this is the same as Mr. DARP, W star. But for this, we're going to have over here, this is the firm's demand for labor. And so I'm going to put demand for labor by the firm, and that's called the marginal revenue product. And the W star is called the marginal factor cost, because that's the additional cost of hiring a worker. Right? So if we hired 2, 3, 4 workers, each additional worker costs us exactly the same. Well, this curve, the DLF, demand for labor by the firm, is called the marginal revenue product. And that's because each additional worker generates less marginal revenue than the first one or the second one, in this case, because they start to specialize. They should hire the quantity where, as we have up here, MRP equals MFC. And so this is the quantity they hire, and they pay W star. Okay. Now, the last part on this page shows what happens in a monopsony labor market. And a monopsony, is just a refresher, is where you only have one buyer. And in this case, the one buyer would be one firm hiring. One firm hiring. And what we find is actually there are lots of monopsonistic labor markets out there. There are very few that are perfectly monopsonistic. But just like with imperfect competition, right? We've got monopolistic competition and oligopoly and monopoly. And there's a zillion of them out there. They're actually quite common to find monopsonistically competitive labor markets. Now, the graph is going to be the same for a monopsony as it is for monopsonistic competitive. So we're going to use the same graph for that. Now, the demand for labor is defined by the marginal revenue product of those workers, because it's the demand for labor of the firm and for the whole market. Now, the supply of labor is upward sloping, because that's the workers who are willing to supply their labor. But it's not going to be equal to the supply of labor is not going to be equal to the MFC. In fact, we're going to have one of these, an MFC up here. And the rule that we're going to use is the same as up here. Higher MRP equals MFC. So MRP equals the MFC. That's the quantity we hire. Well, how much do we pay them? We pay them what they're willing to work, which is the supply of labor curve. We pay them down here, W star. And so in fact, we are underpaying the workers. Okay, we're underpaying them compared to perfect competition, because in perfect competition, we'd be here where supply equals demand. This is the optimal. And so in the optimal level, right, you'd have a higher wage W opt, and you'd have more workers, Q opt. And so there's an argument to be made in support of minimum wages in these sorts of markets, where you would push the wage up, and by so doing, you would actually increase the number of workers getting hired. Now, a minimum wage up here would just be like this, right? W min would look something like this. And so you would end up reducing the number of workers each firm hires because the demand for labor at that high wage would be low. So you'd have fewer workers if you had a minimum wage in this world, right? And you'd have more workers in this world, and they'd be getting higher wage, which is maybe a little counterintuitive, but that's our model, right? And that's the interesting part of economics. Okay, so hopefully this helps you a little bit. Oh, I didn't shade deadweight loss. I remember to do that really quick. Deadweight loss. There we go. Hopefully this helps you a little bit. I'll see you next time.